Good morning to all the students. Hope all are fine. Welcome back again. In the previous video, we had finished with chapter 12, Introduction to Acid and Base. I hope you all have read the entire chapter and gone through it. Today, I'll be discussing with you all the question answers of this chapter. But before that, we'll just quickly revise whatever we had finished in this chapter. In this chapter, we had studied about acids, bases, indicators, and the process of neutralization. Now, in acids, we had seen that acids were those substances in which the main constituent that was present was hydrogen ion, that is H plus ion. The pH value of acid was less than 7 and the taste was sour. Some examples of acids we had seen: HCl, H2SO4, HNO3, etc. Then we had also studied and seen some natural or organic acids like vinegar, tamarind, orange. The acids that were present in such substances were acetic acid, citric acid, tartaric acid, and so on. The next thing we had studied was bases. Bases were those substances which were bitter in taste. The pH value was more than 7. The main constituent that was present in bases was OH minus ion, that is hydroxyl ion. Then we had also studied about indicators. Now, what were indicators? Indicators were those substances which, when added to acids or bases, there was a change in color which was seen. There were two types of indicators: laboratory indicators and domestic indicators. The indicators that were found at home were domestic indicators like turmeric, radish, cabbage, etc. Now, the laboratory indicators that we had seen was litmus paper, phenolphthalein, methyl orange, etc. What was neutralization? Neutralization was a process in which an acid reacts with base to form salt and water. We had also seen the properties of acids, bases, and neutral substances. We had seen their uses, their characteristics, and the examples. So I hope everything was clear to you all. Just a small correction. On page number 84, the table that is given on the top, just open your textbook to page number 84. Indicators and their colors in acid and base, the table that is given on the top. Just a small correction in that. The third indicator that is given, methyl orange, the color that is found in acid, that means when methyl orange is dipped in acid, the color change that is seen is red color and not pink color. So just change it. Methyl orange in acid is red in color. Now we move to the question answers. So open your textbook to page 88. Question number 1. You can mark the objective questions with pencil in the textbook and then later on you can write it. The question answers of this chapter will be sent to you all in the assignment section. So later on you can copy it down. So now there is one table that is given for question 1. Based on the change in the indicator, we have to identify whether the given substance is acid or alkali. First one, for phenolphthalein they have mentioned no change. Now we know that the color of phenolphthalein is colorless. Now if phenolphthalein is added in a particular substance and if there is no change in the color seen, that means that particular substance is acid. Because When phenolphthalein is added in acid, it remains colorless. No color is changed. Now suppose if this is acid, then what change will be seen in methyl orange and litmus paper? Methyl orange will change to red, and in litmus paper what change? The blue litmus paper will turn to red. So this is the first answer. Since there was no change in phenolphthalein, it is an acid. Methyl orange will change to red and blue litmus will turn to red. Next one. For methyl orange, the orange color turns red. So it's the same thing. That substance is acid. So phenolphthalein will remain colorless, or you can even write no change, because phenolphthalein, the original color is colorless only. So if it is added in acid, it will remain colorless or no change in the color will be seen. And same thing for the litmus paper also. Blue litmus paper will turn to red. So first two substances were acid. Now third one, they have given red litmus paper turns blue. Now red litmus paper turns blue, that means it is an alkali, or you can say base. So if it is an alkali, the phenolphthalein color will change to pink and methyl orange will turn to yellow. So I hope you have understood this table. Take down the answers correctly. We move to the next one. Question number 2. Write chemical names from given formulas. Now there are some molecular formulas that are given. From those formulas we have to identify the chemical names. First one, H2SO4. Now what is the chemical name for H2SO4? It is sulfuric acid. Second one, CaOH twice. What is CaOH twice? The chemical name? It is calcium hydroxide. Third one, HCl. It is hydrochloric acid. It is also called as hydrogen chloride. Both the names are correct, hydrogen chloride or hydrochloric acid. Then fourth one, NaOH. NaOH is called as sodium hydroxide. Fifth one, KOH. KOH is called as potassium hydroxide. And sixth one, NH4OH. The chemical name is ammonium hydroxide. So you have to remember the chemical names. H2SO4 is sulfuric acid. This is calcium hydroxide. Hydrogen chloride or hydrochloric acid. Sodium hydroxide. Potassium hydroxide and ammonium hydroxide. Question number 3. Sulfuric acid has highest importance in chemical industry. Why? Now, why does sulfuric acid have importance in the chemical industry? What is the reason for that? You have to write sulfuric acid is used in manufacturing fertilizers. So different fertilizers are made by making use of sulfuric acid. It is also used in the manufacture of dyes and paints. It is also used in manufacture of different explosives. It is used in the batteries that are used in the cars. And it is used in the manufacture of drugs. So because of all these reasons, sulfuric acid has the highest importance in chemical industry. Question 4. Give answers. In that first one, which acid is used for getting chloride salt? Now, which is that acid that is used to obtain chloride salt? The answer is hydrochloric acid. So, hydrochloric acid is used to get chloride salt. What is the formula for chloride salt? Which is the chloride salt? NaCl. So, hydrochloric acid is used to get chloride salt. Second one, by squeezing lemon on a piece of rock, the gas liberated turned lime water milky. Which compound is present in the rock? Now, when any acid reacts with carbonates, it liberates carbon dioxide gas. This carbon dioxide gas turns lime water milky. So, therefore, the carbonate compounds are present in the rock. So, that rock which was present, it was made up of carbonate compound. So, when acid comes in contact with that carbonate compound, the gas which is given out is carbon dioxide gas, and it makes that particular rock or any carbonate compound whitish in color. So, it makes it milky. Third one, the label on the bottle of chemical is spoiled. How will you find whether the chemical is acidic or not? Now, if there is any bottle and you don't know whether the substance in it is acid or no, how will you identify it? By making use of different indicators. So, you can take a litmus paper. Now, if you want to find whether it is acid, so you will take a blue litmus paper. So, when the blue litmus paper is dipped in that particular bottle, and if that blue litmus paper turns red, that means that given solution is acidic. If there is no change in the color form, or if it remains the original color, that is, it remains blue only, that means the given substance is not acid. Also, you can do this by making use of phenolphthalein. Question number 5. Answer the following questions. In that first one, explain the difference between acid and alkali, or you can say acid and base. Difference between, as I had told you all earlier also, minimum 4 points has to be there. First one, acids are sour in taste and bases or alkalis are bitter in taste. Acids turns blue litmus red and bases turns red litmus blue. Acids change methyl orange to red and bases change methyl orange to yellow. Phenolphthalein remains colorless in acids and phenolphthalein gives pink color to bases. Acids do not give soapy touch and bases give soapy touch. Now, what do you mean by soapy touch? That means when the bases are little bit slippery, a kind of soapy structure. Now, when you touch the soaps which are there at your homes and all, you must have seen its structure. When you touch it, it's kind of little bit slippery. So, bases are like that, but acids are not soapy. Acids give hydrogen ions in solution, that is H plus ions, and bases give hydroxyl ions in solution, that is OH minus ion. So, this is the difference between acids and bases, that is acids and alkalis. Second one, why indicator does not get affected by salt? Now, we had already studied indicators are those substances which when added in acids or bases, they change the color accordingly. but indicators do not affect any neutral substance. Now we know that salt is a neutral substance, water is also a neutral substance. So when any indicator is added in the neutral substance, there is no change in the color found. Indicators change their color in presence of acids or bases. Salts does not show the properties of acid or base. Therefore, indicator does not get affected by salt. Third one, which substances are produced by neutralization process? What is the answer? In the neutralization process, the substances that are produced are salt and water. Simple questions with simple answers. I don't think now this lesson will be that difficult for you to study. Fourth one, which are the industrial uses of acids? Now you can copy the uses from page number 86. There are 6 uses of acids which are given. First one, acids are used in the production of chemical fertilizers. Acids are used in the production of explosives, oil purification, medicines, dyes, and paints. Hydrochloric acid is used for the preparation of different types of chloride salts. Dilute H2SO4 acid is used in the batteries, that is electric cell and all. Dilute HCl is used for sterilization of water, and acids are used for making of white paper from wood pulp. So these are the uses that you can write for fourth one. We move to the next question. Question number 6. Select proper word given in the bracket and fill in the blanks. Now even though the question is select proper word given in the bracket, now you can see in the textbook there is no bracket given, there are no options given. So you just have to write the answer in your own words, or you can say on your own. The first one, main constituent of acid is dash, so that is H plus, hydrogen ion. Second, main constituent of base is OH minus, that is hydroxyl ion. One thing that you all need to remember, the plus and the minus signs that are written on the top, that is in the power. Don't write it in front of the letter. It is always written on the top, H plus and OH minus. So main constituent of acid is H plus, or you can write hydrogen ion, and main constituent of base is OH minus or hydroxyl ion. If you are writing it in words, then make sure that you write ion word, hydrogen ion and hydroxyl ion. Third one, tartaric acid is a dash acid, so our answer is natural acid. You can even write organic acid over here for the third one. Both the answers are correct. Tartaric acid is a natural acid, or tartaric acid is an organic acid. So both answers will be correct. So I hope you have understood this question 6. Now question number 7, match the pairs. Now I am directly giving you all the answers. There are 2 groups which are given, group A and group B. First one, tamarind. Now which acid is present in tamarind? The acid present in tamarind is tartaric acid. So the first answer will be tartaric acid. First is C1. Second one, curd. Now which acid is present in curd? It is lactic acid. So second question is D1. Option D. Third one, lemon. The acid present in lemon is citric acid, B1. And the last one, vinegar. The acid present in vinegar is acetic acid. So fourth one is A. So tamarind, tartaric acid, curd, lactic acid, lemon, citric acid, and vinegar, acetic acid. Write down correctly. Now we move to question number 8. State true or false. In that first one, oxides of metals are alkaline in nature. Now if you all remember, we had done this in chapter 7 also, metals and non-metals. So oxides of metals are alkaline in nature. Is it true or is it false? What is the answer? The answer is true. Oxides of metals are basic in nature, that is alkaline in nature. And oxides of non-metals are acidic in nature. So you have to remember the difference. Any question could be asked. Oxides of metals are alkaline in nature and oxides of non-metals are acidic in nature. Second one, salt is acidic. Is it true or false? Is salt acidic? The answer is false, because salt is not acidic, it is neutral. Third one, metal corrodes due to salts. That means the corrosion that takes place on the metals, is it because of salts? What is the answer? True or false? Does the corrosion take place because of salts? The answer is false. The corrosion doesn't take place because of salts, but it takes place because of the acids that are present. Fourth one, salts are neutral. The answer is true. So I hope you all have taken down it correctly. First answer is true, second is false, third is false, and fourth one is true. Now question 9. Classify following substances into acidic, basic and neutral group. Now for this, you can make 3 columns, one for acidic, one for basic and last one for neutral. And the substances that are given here, you can just put it accordingly in the group. First one, HCl. Now is HCl acid, base or neutral substance? What do you think? Yes, acid. HCl is an acid. Same way, NaCl. NaCl is sodium chloride. So is it an acid, base or neutral substance? Sodium chloride is a salt. That means it is a neutral substance. MgO, magnesium oxide. Magnesium oxide is a base. KCl, potassium chloride. Potassium chloride is a salt. So potassium chloride is a neutral substance. CaO, calcium oxide. Calcium oxide will be base. H2SO4, sulfuric acid. That means it will be an acid. HNO3. HNO3 is nitric acid. So it will come under acid group. Next, H2O. H2O is water and water is neutral. And last one, Na2CO3. What is Na2CO3? Sodium carbonate. Sodium carbonate is a salt. Therefore, it will come under neutral group. So you can make a table like this: acidic, basic and neutral. So all the acidic substances you can write it together: HCl, H2SO4, HNO3. Basic substances: MgO, and CaO. And last one, neutral substances, NaCl, KCl, H2O and Na2CO3. So I hope you have understood all the questions from this chapter. Take down the answers properly. Go through it. If you all have any doubts, you can send your doubts or we can discuss it during the live class. Make sure you complete your notes whenever you receive it in your assignment section. So till then, have a nice day. Thank you.